Okay, we're continuing with rational expressions here, and we have complex rational expressions, and we've actually seen we've seen the very same thing before, but they're going to get pretty challenging. But let me show you. So a complex rational expression is simply where we have a fraction over a fraction, but all it means is division. It just means the top divided by the bottom. Well, we've seen this before. We're just going to keep the first one, change it to multiplication, and flip the back end upside down. Okay, well, let's see. Yeah. Now, once you're there, make sure you factor down in case there's anything that can cancel, and we get this. Now, they're going to get pretty terrible in a minute, but let's just see that this is the same idea as this. Same thing. We've done this before then. So that's keep, change, flip. Now I'm going to factor this to make it 2 over x minus 1, x plus 1. Now we've done this several times. Remember, anything on the top can cancel with anything on the bottom, and we're left with 2, and we're done. Alright, same thing. Pause the video if you want to try it on your own. Now I'm going to go ahead and factor this, and I'm going to get x. What do I get? Now that's the first one. Now this is division. I'm going to change it to multiplication, and I'm going to flip this guy upside down. Okay, keep the top, change, flip. Now I've got the match. Now you've got to leave something on the top, so I've got 1 over 2 times x minus 3. Okay, now this is what you're not going to like very much. This is actually like 3 problems inside of itself. We know how to do what's here on the top, so we're going to work that. We're just going to combine those fractions, and we know how to do what's on the bottom. We're going to do that second. And once we've worked those 2 individual problems, then we've got a problem. Problem number 3 is keep, change, flip. Now I'll let them show us one here. They're going to do it at the same time, but they're just getting a common denominator. They're working the top, combining everything. They're doing the same on the bottom. Oops. Now they just add it up. Now they get to here, so they work the top, they work the bottom, and now we've got keep, change, flip. Keep the top, change it to multiplication, flip it upside down. The 6's cancel, and I get a 3. Okay, now let's do this. I'm going to work them. I literally work them as the steps here, so I'm going to do this all as if it's the only problem in the world. I want these to both be over 6, but I'm going to multiply that by a 3 to get there. Got to do it to the top, and this one by a 2. Got to do it to the top. So I've got 3 over 6. Oh, you know what? I like to do it this way. I'm going to do 3 over 6 plus 4 over 6. Now that is 7 over 6. Okay, now I've done the top. That was problem 1. Let's do the bottom. That's problem number 2. 5, 6 plus 1 over 12. Now let's make these both over 12. So I'll multiply by 2 on the top and the bottom over there. I've got 10 over 12 plus 1 over 12 is 11 over 12. Okay, now we have the top, we have the bottom. It's all being divided, so we keep, change, and flip. And we can reduce this. And we get, now remember, you multiply across the top, so I get 14 over 11. Okay, I'd recommend you try this one on your own, but I'll start going here. I'm going to do this first. I want a common denominator, and that's going to be 12. So I'm going to add a 4 to this side and a 3 to this side. And I get 9 over 12 minus 4 over 12. Now the denominators are set, so I can just subtract. Okay, now I think this one has to turn into 24. So just going to work my magic here. I get 3 over 24 plus 20 over 24, 23 over 24. Okay, they were over top of each other. So I'm going to keep the first one, change it to multiplication, and flip that guy upside down. All right, let's cancel. I got a 12 and 24. That can reduce to be a 2. And I got it. Now we're going to introduce variables here, but this really doesn't change anything. We know how to do them as individual problems. Nothing's changed. So while I got the chance, let them do one here. This side needed a y, so we're just doing the top first. I would be doing just the top. You add a y to this side and next to that side. Now you can combine them. That's the top. This one needed an x on the bottom, y on the bottom. Combine them. So basically we're doing exactly the same thing. Okay. Now we get to this and we keep change flip. That's going to allow you to cancel out a whole bunch of stuff. I would have canceled those right there. You can factor this, get all the way down to there. Okay, now I know that seems like madness, but you already know how to do it. Let's do one together here. So we're doing the top. This side needs a y, so I'm going to give the top a y. This side needs an x. I'll give that an x. Okay, now I'm going to go ahead and finish these. They're both, I know it's x, y, or y-axis, the same thing. Doesn't change anything. And I know there's ones in front of them, but those don't mean anything either. So I'm going to create that for the top. Now, this side needs a y, so I'll give one to the top. This side needs an x. Give one to the top. Okay, now they have the same denominator, and so this is going to be y minus x over xy. All right, we did 2 problems just to get to the third one, which is keep, change, flip. I'm going to turn it to multiplication, flip this upside down. Cancel, cancel. I get y plus x over y minus x. And I'm there. Okay, let's do another one. I'd recommend you try it. I'm going to go ahead and start. Just going to do the top as if it was the only problem in the whole wide world. He needs a B, but I got to give one to the top. He needs an A, got to give it to the top. Okay, this becomes B plus A over AB. Again, the bottom being reversed doesn't matter. Now I'm going to do the other one. Okay, this needs a b squared. This needs an a squared. So I'm coming over here. The tops can be put together now. I'm subtracting them, but b squared minus a squared over a squared b squared. Okay. Now all of that just to do keep, change, flip. All right, now this is a little harder. I'm going to write this again. So let's factor down. And I'm going to show this as, isn't a squared, isn't that true? There's two a's up there, two b's. This is b minus a, b plus a, because it was perfect squares. Okay, now an AB can cancel with an AB, and a b plus a can cancel with a b plus a. And what I'm left with, I don't know where to write it, AB over b minus a. All right, nothing really changes here except that we're just going to make the n over top of a 1. So I'm going to put an n over a 1. Well, that's fine. This side now needs an n plus 5 on the top and the bottom. Everything else stays the same. Do all the madness we did before. Keep, change, flip, factor everything down. Okay, it's the same. All that is n over 1. So let's do one here with this b over 1. So I'm going to do b over 1. Okay, this side is going to need a b plus 5 on the top and the bottom. Okay, let's multiply that through. I'm going to get b squared plus 5b. Over here I've got minus 3b over 5 plus b. Now this is subtraction, so he's going to this guy. So I'm going to have b squared plus 2b left on the top there. Now let's do the bottom. This is part number 2. Okay, he needs a b minus 5. He needs a b plus 5. Okay, let's distribute, and I'm going to get 2b minus 10. I'm sending that 2 just to both of those guys. 1 times b plus 5 doesn't do anything. Okay, they have the same denominator. Got 3b minus 5. You see I'm just adding across there, putting together the like terms. Okay, now do I have a GCF on the, okay, never mind. So got the top done, got the bottom done. Now they're being divided. I'm ready for problem number 3, which is keep, change it to multiplication, and flip it. Yeah, I remember this one. I was expecting a lot more to cancel, but it doesn't. That will cancel. And we have a GCF of a b here, but it's not going to cancel with anything. So I'm just going to leave it as b squared plus 2b times the b minus 5. Just moving everything over on the top, over everything that's left on the bottom, and I'm done. Oh, that's not a 25. That's a 2b. Okay, I'm going to just status check here where we're at, what we got left. Okay, last slide. Okay, so it's the same thing, but I'll go ahead and show it here. Got 1 over 1. So I need a c plus 4 on the top and the bottom. So I get c plus 4 over c plus 4 minus 3 over c plus 4. Now the denominator is the same, so I'm going to just put the tops together. I got c plus 1 over c plus 4. Now let's do the bottom. This side needs a 3. I'm going to put it in front because we usually will send him through maybe. He needs a 3 on top. This side needs a c plus 4. Okay, so we've got so I just multiplied that c through. Okay, so let me tidy this up here. I got c squared plus 4c plus 3. Just putting the top together over 3c plus 4. Now all of that, I did problem 1. I've got problem 2, so let's keep, change, flip. Keep the top. It's got to be the top. So if someone misses this, they flip the wrong thing. Keep the top, change to multiplication, flip the second one. Okay. Now I can do some factoring here. All right, this guy cancels with that guy. This guy cancels with that guy. And we're left with 3 over c plus 4. Okay, I know that seems really difficult, but it's fine. It's just 3 mini problems. You know how to do them all individually. You just have to put them all together.